Welcome to the APL show. I'm Adam Brutzewski.
I'm Richard Park.
Today we're doing another episode on APL primitives, Extravaganza. This will probably be a long, intermittent series of episodes with all our dreams and hopes and fantasies about what.
Right, I mean
APL might
APL's
go.
been in progress for 50 years
More, yeah.
more. So there's no it's not like the story's finished. It's not like we've done all the primitives.
Well, there can always be more primitives to add, but it's not always as a good idea. Fantasizing about them is, of course, always a good idea.
Yes.
Before we get to that, just a couple of announcements. Some upcoming events in this next month or so. On the 9th of May, FinAPL have their spring meeting. It's a actual physical meetup. So if you're in Northeastern Europe, then that might be something to look into. And on the 15th, on the other side of the globe, then the Tokyo APL JK meetup is happening. So if you're over there, might be something to look into there. And then just recently, Dalek published the formal proposal for the APL array notation. That's something I've been working on and off since 2015 when I saw a talk by Phil Last at the APL user meeting in Sicily. And now we have the formal proposal, finally, which I think we have to change a little bit, but that might be happening by the time you hear this.
Yeah, well, that's the point, isn't it? Of getting
That's
putting it out there
yeah,
for feedback.
exactly. And that's why we want to discuss all of these kind of things and even discuss, primitives and so on. APL goes on forever, at least apparently.
So far.
In the history of computing, APL has always been there,
Yeah.
more or less. And the design decisions that are made for APL are really important because we stick with those. And APL is not really uniquely, but it strongly maintains backwards compatibility. Very little old APL code will not run today on any modern APL interpreter. And that's really a core value as well. So we really have to be careful about the design of things. And mistakes happen, absolutely. There are various things that could be done about that. But array notation is a little bit different than what has kind of ever happened before. There was the addition of strand notation, which is just juxtaposing things, make them into a vector. But this would really extend the syntax, really adds a bunch of new syntax to APL. We don't want to mess up. So feedback on that would be good. We'll leave a link. And with that, let's do primitives. So last time we spoke about primitives, we went through the primitives that are supposed to go into Dialog version 20.0, probably like next year or so.
Yeah, if all goes well, if they don't
Yeah.
find major objections.
Or issues with implementation. I don't think there would be.
No, they seem, yeah.
It's not that it's going to be. There's nothing controversial there. We're talking about
No.
the select primitive, which is just filling out the last parts of indexing. Nothing special really there. And then there is the depth primitive, which is very much like rank. And there shouldn't really be any issues there. Some performance issues might be interesting in the implementation. It kind of has to recurse on this. It can recognize certain cases and do those faster. And then there is the reverse compose or before, behind, or whatever you want to call it.
We should probably figure out what to call it before.
Yeah, I don't personally care much about the names of APL primitives. I don't think of them in terms of the names. It's only necessary when I communicate with other people by voice, like podcasts. And then
Yeah, well, exactly.
and you also adapt the name according to what we're trying to do. And even if we give good names to things, people will just use other names. Like who says index generator? Well,
Well, this was
index generator 10, right?
was this
IOTA
a whole
10.
array cast thing about the combinators and uh, like they've not, because this is another. Well, it's an operator. It's not really compositional. It's like one of these.
Which one?
Oh, it is. Sorry, this is exactly composition. Yeah, this is exactly in the realm of those, combinators that like have been written about, people know about, but no one's got a good naming convention for them,
Yeah,
right?
they're hard because they're kind of abstract in what they do. It's not
Yeah,
very
exactly.
concrete, and it's not that you cannot really draw many parallels to our physical world, which you could with other things like reversing an array and transposing and so on. You call that flipping. I think K calls it flip transpose. Um, but the applying one thing and then another one. I
Hmm.
mean, you could call and then a top would be and then, but then it's in reverse order of the reading order,
F
right?
and then a G and then F.
Yeah.
F after, and then that's the temporal thing, which isn't.
This is what BQN does, right? It calls them the temporal things before and after.
Yeah, I don't mind that. I guess we've got the problem that we've already called some things things.
The spatial things beside a top,
Mm.
over. What's the difference between a top and over anyway? And then I was looking at that. There's this page on the APL wiki for German names for things
Oh
because
yeah.
Germans like using German names for things. Uh, and I was trying to use Google Translate to translate a top and over. That doesn't really work because they just end up being the same. Those two words are synonyms, right? So
Yeah, the thing that's I guess in the diagram of like function with arguments either side. This is another thing, right? Is that we're doing it in the syntactic paradigm of like Iversonian APL languages, which is like prefix, infix, and then your
operators are
short left
suffix and
scope,
infix.
long
Yeah.
right scope, right precedence. Whereas in the sort of functional world at large, they don't have this. Would you call it a limitation? They don't have this way of thinking about it, right? An argument is actually just a list always. Or
Yeah, I guess the
argument
syntax
is a
there's
list of arguments always.
I've seen complaints that APL has complex syntax, which I don't think is the case really. But there is a syntax, and the syntax is good, and it makes it easier for people to manipulate the expressions. And there is a syntax. Whereas you could say that for something like the things written in lambda calculus and like the uniform,
Algol-esque.
yeah, the uniform function calls, function name, open paren, argument, comma, argument, close paren, that kind of thing. You could say there isn't really any syntax. Of course, this is a syntax by itself, but it's a kind of, I think of it as a giving up on trying to make a good syntax. Same thing goes for the
Yes.
the Lisp style, where it's just function name, then all the arguments right after it, and then parentheses around the whole
Right,
thing
but
if
sometimes we
necessary.
revert to that in APL too, when you have a function where it's in principle it's like takes some number of arguments, but actually you're passing a vector of some length, or it could
Yeah,
be, short, and then you're filling in. You're saying the first one, if it exists, is this. The second one, if it exists, is this other thing. You don't even get that niceness of. I mean, this is where array notation actually it might open a bit of floodgates towards a slightly more Pythonic thing. If you can write a literal namespace
right.
as like key value pairs, then you get that. I don't know if does JavaScript do it as well. I know Python
Yeah, yeah,
does,
sure.
where in the list you can put name equals value, and then you're sort of you don't have to worry as much about the order
Yeah,
of
sure. I
those
mean, you can
arguments.
feed a JavaScript object to a JavaScript function, assuming it knows how to handle that. And things like I remember jQuery has this duality of syntax. You either give it parameters or you give it an
Or it's a
object that
method.
that has all these. Well, it's always some kind of method, right? But the argument to it is either a namespace, meaning a JavaScript object
Yeah.
that is populated or partially populated, and it assumes default values for things that are not populated,
Mm.
or it is just a list of parameters
Yeah, I see.
in an order. And we actually, yeah, we kind of have that in dialog, except we don't actually have the namespaces there. But for things like quad WC style
Right,
object
that's kind
generation,
of what I was thinking of
yeah, or
as the
I
prime
mean,
example.
there you can either give them ordered arguments, which is a prefix of all the possible parameters, or you give them name value pairs, which are not namespaces, but it might as well have been a namespace notation, just a clunky one.
Yes, yeah.
Um, so
And to bring it back now we need to rope Connor into this because so if you don't have this idea of applying to a left, they must think about it in terms of infix, right? If they have different names for combinators in the functional world
no,
that
it's not infix at all.
depend on if so what's the difference between a function applying to oh, it's you've got two arguments in a list, and it's whether you like do something to the first one first and then the second one, or the first or the second one first
Yeah,
and then the first
but
one.
but generally that you just
So that's
choose
not
an
left and right, is it? Right,
no,
yeah.
no, and generally you just choose an order to make it look
But then that's a
nicer.
combinatorial. I guess that's why it's called nightmare, isn't it? Because that just goes on forever, right? If you've got, oh, what's the name? What's the name for a combinator or a function composition operator, higher order function that takes 6 arguments and it does this thing to the first 3 and does
Yeah,
something to the next one and then something different to the next 2. Like, okay,
yeah.
so I mean,
There's no end to it. I
just give
mean,
up then, yeah.
there aren't nearly enough bird species to give names to all the possible combinators. But which is yeah, I think that's also
Also, by
implicit
so
in this.
by yeah, APL BQN taking a stance, at least you get to limit
Yeah,
that.
right. Once you want to go above 2 of each thing, arguments, operands, then you have to choose a different way of doing it, which is going to be less elegant, but more general purpose.
Yeah,
There's a list of things.
and I guess they have that in that world where they're like talking abstractly about function composition. Uh, there's like letters, so there's letter names.
Yeah, that's yeah.
Just remember what the letters are.
But that means also that they actually have a less of a distinction. They would not distinguish between what should we say, the forward and reverse compose. They don't distinguish between what we would say, F and G, and we pre-process the right argument with G and then feed that into F for the main processing, or pre-processing the left argument with F and then feeding the result into the main processing with G. From the combinator perspective, those two things are equivalent. It's just a matter of which value goes where.
Hmm.
But for an APLer that's trying to design some kind of domain-specific language or clean up his code, that makes a world of a difference. So I even have this idea that it might be worth adding a primitive, which is exactly like the exponential power function, but with the arguments reversed. And that's the only difference from the current power. And people might say, oh, well, that makes no sense, right? Those are that's the same thing. Why would you do that? Wait, what's next? You want to do minus the wrong way too? And
Yes.
division? Maybe.
Minus division mod. Well, our mod is
Mod is already fixed, but its
already
division is wrong. um, but my argument is that the power we have is the inverse of the logarithm, where the base goes on the left. So it's e to the power of something, and then it's the e logarithm of something, or say the 10 logarithm of something, and the 10 to the power of something.
yeah.
But there is another type of power, which is the inverse of the root. So it's the third root in the cube root of something. And so too, it would be the third power of something. Also because as opposed actually to traditional mathematics, the parameter goes on the left and the main data on the right. So when I'm squaring a number, it's clear that the number is the main thing and the parameter is the 2 for the square. When I'm
Yeah.
taking the cube root of something, it's clear the parameter is the 3, the cube thing, and the main data is the one that's being cube rooted. And so the inverse of the
In
square
what?
root,
In what notation?
well, I mean,
For the root,
no,
sorry.
just a normal root symbol, yeah. And there some APLs even have a
That's
root.
only because it's little.
No, no,
Yeah, the 3 goes on the left.
yeah,
The n goes on the
but it's
left.
not because it's little. I mean, even if in those APLs that have a root function, there's just a big number on the left. But even there, surely you would say that the 3 in this cube root is the parameter,
Yeah,
not
so
the main data.
right, but what aspect of that in the notation indicates that it's the parameter?
No, it's just that it's on the left. Parameters go on the left. And a function that does not take a parameter, it just does its one thing, doesn't have a parameter on the
Well,
left.
now it's just like the semantics of how you I'm thinking about divide now, of
Mhm.
like how you phrase that in your head.
I want to have something, or split it in 3,
So
or
you divide by 2,
yeah.
but
But the
divide by
parameter is the
3.
2, not the main data.
Well, like for the traditional symbol, it goes on the right.
Exactly,
Right,
it's
but in
wrong. It should be
APL,
on the
yeah,
left,
yeah, yeah, yeah.
which is why mod is like that. You barely ever want to do the n mod of some constant. You always want to do uh, the
Constant mod of
2
a
mod
bunch of
of something, or
stuff.
10 mod or something, or
Right.
whatever it might be. 256 mod of something. That's the parameter there, and then the main data that's being transformed is on the right. That's how division should be too, and then that would change the language completely, because then monadic division would be what exactly? And but
Yeah.
yeah, okay, but then I'm sure something could be figured out. Tearing down everything here.
Yeah, that's right. That's right. That's right. We break everything. We just say it's wrong. We want to fix it so it has this consistent sort of what do you call it? I don't even know what's the word for this consistent semantics or whatever, or
Yeah,
syntax really.
but I mean, it could be, right?
Um,
Why is monadic division in APL the reciprocal? Because then it works out that you can have a default value, which happens to be also um the identity element, but whatever. I'm not sure that's actually
all
so
right, same with
relevant.
minus.
Same with the minus, and
Almost plus, except for the complex conjugation.
yeah,
It's
and
like 0
that's but
plus
that was
in a
shoehorned
way.
in there later, right?
Oh, the complex conjugation. Yeah, yeah.
Yeah, but I mean, but if we hadn't had that, let's say that we weren't restrained,
That's true.
or
What's
Iverson had decided not to stay with the order of arguments in division, then maybe division and multiplication monadic would be something else. It could be, think of it like this. So um it's the same, yeah, same thing go for minus, right? So let's say that
hmm
minus was fixed like that. Let's say that that monadic minus would be decrement, and monadic plus would be increment, and then monadic times could be double, and monadic division could be half, because the parameters on the left, so it's
Mm.
divide by 2, for example. And then monadic power could also be square, right? And monadic root would be square root. Then they all fit. And then everybody would get so confused because minus is not working the way they expected to.
Right.
But I think
And I also think
MATLAB
that
has backslash as divide left, as in like
oh,
thing.
it's the division, but the other way around.
Yeah, slash and backslash. Got that
Yeah.
right.
But it's like you're saying, I want to divide. I want my data. It's true. Most of the time, you want a bunch of numbers divided by one thing.
Yeah, a
More,
constant usually.
more than you would want one thing divided by a bunch of parameters, like
Yeah, very often
quarters
we
of,
do
halves of.
exactly or twice the value of something, 10 times that, I mean, 100
Unless
times that.
you're doing like, yeah, these arithmetic series, different series and stuff, then you might. Yeah, that's
Yes.
the problem with trying to make something general.
I
And you're
mean,
right.
yeah, and so there are cases when I would use division and subtraction the way they're written, but often they end up being commuted. So, I'm just saying, okay, there's no end to the number of primitives you could add, right?
Yeah.
But the question is it a good idea? Eventually, the vocabulary becomes so big. Look at
Right.
the
It's the
UK.
question really is, and we were looking at this on the formal descriptions of no. No, we were past finite processes. What was the last Iverson paper we were reading?
Yeah, that was it was yeah, formalism in programming languages.
Formalism in programming languages. And the discussion
We should
there
fill
is
in a little bit of a background here.
very much
Internally
mirrors
at
this.
Dialog, we go through old APL paper and Iverson papers to educate ourselves and be better prepared for developing the language onwards. And so we are going through them in chronological order, a selection made by Roger Huey, and we have now read formalism in programming languages. We can link to that. That's a really interesting paper, actually.
Yeah, this one's really good. A, the people in the group seem to like it, but B, it kind of ties together because the previous papers we were reading are clearly like building up stuff, right? And the aspects of the notation change quite a lot, right? So we talked about this on very early episodes of APL show, the Iverson notation sort of pre-APL APL and stuff.
Proto
So
APL.
yeah, so it's not linearized, it's got superscripts and subscripts and things like that. But the discussion I think in this paper, the formalism in programming languages, really reflects like it's the core, it's the like what is a primitive in APL and why should it be one? Which is like what are you trying to do? The discussion, what's the language for, right? Iverson even says, I don't think it's possible to make one language that will be
Good
how
for
does he
everything.
call it?
Yeah.
Yeah, it won't make everyone happy,
Right.
but like in every aspect, right? Because you're going to, for specific applications, you're going to want features close to hand, which is what, well, I'll talk to that. I'll talk to that point in a second. You want features close to hand that other people are going to think that's kind of, I don't really need that. I mean, one primitive that we still have in Dialog APL that kind of is like this, I'd say, is Domino.
Mm-hmm. That's
That's the one in
matrix
like
division, matrix
inverse,
inversion. Yeah.
which is like, yeah, if you're solving, um, simultaneous linear equations.
Or even power equations. You can map them, but down to that.
Right. Oh yes.
See Apple Cart.
Starts doing some logs and stuff.
Yeah.
Um, and I'm sure you can do all kind. I'm sure that's exploited a lot just through transforming things or approximating things until they're linear equations, and then doing some inverses.
Yeah.
But a lot of people doing business applications aren't reaching for that a lot, and the people who are reaching for that a lot are actually looking for features to do with like highly optimized, high performance specific cases where you might not need every like value computed exactly, or things like that. So a question of whether that should be a primitive. But then Iveson does say about, okay, but what he's aiming for is like a core language that can then be extended in ways that are going to be generally useful, or the core language is so generally useful that its extension makes sense. I suppose I'm paraphrasing a lot here from like half remembered. I'm trying to also trying to scroll through and see if I can get the exact quote, but I'm not like good at speaking and skim reading at the same time.
I think maybe the domino is a step too far, but
Here we go. I submit that no one can design a language that is equally useful for everybody. Instead, what you would like to have is a single core which you can extend in a straightforward manner. Duck while the Lisp people throw things at us for claiming that the APL is the core that you want and not the lambda calculus or whatever.
yeah.
But,
To each their own. I prefer APL syntax.
yeah, so what do you so then what people traditionally do, and still do, is make the straightforward manner of extension in APL is a DSL, the domain specific language.
And it
Uh,
often ends up looking really nice,
yeah,
and pleasant to use.
you just like name small snippets appropriate to your domain, and then write the code in a way that ends up reading quite naturally, which is
so
nice.
some people would then argue that you should be allowed to give meaning to additional symbols that are not currently defined.
I
Um,
am slightly in favor of that, but not I. The drawbacks, the risk is I can understand is very high.
well, yeah, it leads down a slippery slope. If you allow that, then you must also allow overriding meanings. Otherwise, you can never extend the language further. And if you allow overriding meanings, that means you cannot trust the primitives to have their original meaning when you just see some APL code. So you jump
Yeah.
into a code base, maybe the primitives have all been redefined or fixed or whatever. And and
But
and
like I could argue that for any given code base, the effort to understand like the DSL that they've set up could be comparable to I might as well just remap the meaning of the symbols.
yeah,
Now, if you get really used to the symbols, that's hard. And then the other thing is, yeah, really in two minds about it. You know, people define terms all the time anyway. Now, not common. Yeah, no, they even repurpose common words. This is like the whole thing about naming these combinators, right?
yeah.
We're not talking about birds when when people are using birds. They're just like using words that are. I mean, that one's completely arbitrary, I guess.
Just
So
a
yeah,
large
people
vocabulary.
repurpose tokens and words all the time. It's not even a. I mean, I can't say it's not even a problem because it's clearly a problem,
Sometimes.
right?
Yeah.
Yeah, the alternative is we need to like get comfortable with like inventing new sounds that don't belong to the language we're speaking, and then
No, but I really like the distinction in APL. You have the symbols; those are like set in stone. They can only mean one thing. Well, migration level, whatever. Um, and
Mm.
then you have system names which begin with a quad. User can't create more of those either. They are whatever ships with the system that you're using, and they're interfaces to all kinds of useful stuff. And then you have user-defined names, which are not decorated, but they're also just in Latin letters. Um, and maybe that could be extended, so you could be allowed more alphabets and things, though homoglyphs might be a problem.
No, so the point is that the the Latin glyph, you know, the names that a user chooses
Hmm.
defines the application, and then everything else. If you need to go deeper, you can, you know, you understand what that DSL is made of because the APL is consistent and it's just glyphs, and people haven't added new squiggles and repurposed glyphs. Although again, you know, Duck, Aaron Sue throws a shoe at you because he's, you know, a fan of. He has one letter uh, names, right? Which is kind of, is that not
Kind of symbol thing.
a kind of yeah, he's like trying to be
Yeah.
symbolic with it.
I mean, I do that too, but they can be mnemonically chosen. They can be chosen for the shape of the letter. It's true. But I still know the
Mm.
Latin alphabet and I know the APL alphabet if you want.
Yeah, yeah.
And I can instantly recognize whether this is something that I need to make sure I understand the meaning of or not. And yeah, you could use the same name over and over again to the point where you forget that it's something you defined. Aaron Su did this thing with the indexing function.
Oh yeah, I.
Select, yeah, and it just shows us on slides and things and never bothers to define it because it's just a given term. Right? Oh, oops, didn't define that. Well, because it's always the first thing he'll define. Hopefully that will go away with select. Um, and then
I quite like the choice of I, capital I is the letter for that though, because of its sort of visual similarity with like you know,
The
square
squad.
brackets and squad.
Yeah,
And
so
it's
yeah,
like
squad.
square brackets is the original APL indexing, and that's like, yeah, two square brackets, but clearly there's a gap horizontally between them.
Yeah,
And then we introduced the function version of indexing, which is a squish quad. It's called squish quad, but it's not a
it's
squish
really
quad.
wrong,
It's
right?
actually it's a squacket. It's
It's called Squack it. We should start
it's
calling it that.
it's the two square brackets without a space between them. But if you just keep going, you just keep pushing them in that direction, then you
Yeah,
get the
onto
letter
the
I.
exactly
It's
onto the
perfect.
vertical
You know,
bars meet.
I rescind my support for the select primitive. I say we just establish a convention of defining I at the beginning of every single application, like Aaron Su does.
Oh, it's something like the I-beam, and
Oh
who
gosh,
would
never
have been
mind.
the
I take it all back now because, well, the font has to be, yeah,
yeah. I mean, I-beam is low because it's really up tech, down tech on top of each other. I mean, printed on top of each other. So the vertical
yeah.
parts
And also, you
will
shouldn't see that in raw in APL code.
no, but that's just because of how we use it. But that symbol might have been good for indexing. Yeah, it's like a capital lowercase iota. Uppercase iota is just an I.
Yeah.
Let's say indexing, whatever. Anyway, yeah, it's a never-ending discussion whether
Right,
whether we should be allowed to redefine primitives or not, or
well, okay,
add
okay. So
primitives.
moving on to the primitives that we'd sort of lined up to talk about here. Um,
I spoke about some of these in Germany. I was just at the APL Germany spring meeting, and I basically redid my talk from Dialog 22 about filling language gaps, and then I added two more primitives that are kind of under discussion, which I like to call promote and demote. I illustrated them with the German Air Force shoulder decorations, uniform shoulder decorations. They use
right,
these.
those are chevron
Yeah, exactly.
symbols, which is like a caret, caret, kind of like that,
Or downwards.
or an upside down V
But
shaped.
yeah, yeah. Even that has a name. Upside down carrot is called like it has a
What?
Slavic sounding name, Hatchek or something.
Oh my. You're
And
right, naming symbols is a lost cause as well. It's all
yeah,
just,
forget that.
it's all hopeless. Anyway, yeah,
Oh,
so
Karen.
promote.
It's also called a Karen. I wonder
Oh, there's
why.
a caret and a Karen. Is that what it is?
Charon,
Oh, a
Charon. See where?
caron.
Yeah, like
Chevron and a
carrots, but
caron.
carrot with this.
Chevron is many caron.
No, I don't know. What's a
No, I
chevron?
don't know. It's the thing that's on roads, but it's the same shape. And also the car company Chevron has, co-opted that
No,
symbol as their logo, but it's originally it's a
it's
road marking thing,
a
I think.
circumflex. Yeah, right.
Or
So
it's not.
that's
I
the
don't know if it's originally a road marking, but I know that it is used as a road marking.
it's used to indicate which way you should proceed, right? It's an
I think
arrowhead,
so.
you could
Yeah.
also say. Yeah. Okay. Anyway, so I like to call them and sign and or sign.
But not the ampersand.
No.
Yep. Or two vertical bars.
Right.
Anyway,
One
but
vertical bar.
these are the symbols that are proposed.
Yeah, but
The
that's kind of
neither here nor
minor. The
there.
idea is that they, if we talk about arrays in terms of rank, right? So an array has a rank, and that happens to be the same word as military rank, which I guess is not a coincidence because it's something about like how
You order things.
yeah, but why is it the same word? Why is rank military rank and array rank? Why do we use the same word for that? I kind of want to say, oh, that makes sense, but does it really make sense?
Well, the array,
Higher military rank, you I guess
yeah, it's higher number of. It's just a like, what's the number of dimensions? So that's a way of ordering them.
I guess you could see as a super uniform, no pun intended, military, where you have one person who leads the entire military, the commander in chief, whatever, depends on which country you're in. Um, and then this person has multiple people under
Oh
that
yeah.
each run their part of things, and they have multiple people under them that run their part, all down to the atomic. uh
Soldiers.
soldiers that are just cannon
Scalar
fodder.
soldiers.
Uh, yeah, you can't split those up more because then they die, right? And then no, it's not. We shouldn't make fun of that, really.
We just don't have we don't have a well, okay, 15. The current implementation of dialogue military goes up to 15, but in theory it's not finite, you know. There's always a bigger,
Yeah. Well, how many layers are there in the actual military?
I don't know, but
I mean, there are
probably
many. There are
less than
different
that.
ranks,
Oh,
but
maybe about that.
actual, platoons, and I don't know what these are called,
Yeah.
group units, whatever. Um. Anyway, so
Right.
I guess that's the analogy of the rank, and so the highest rank is the most all-encompassing array that has subarrays of lesser rank. And the idea then is that just like a soldier or somebody in the military can be promoted to a higher rank, which means they'll have more people underneath them, at least in some of this idealized picture of a military, of a orthogonal military. Then you can promote an array to be of higher rank, and you can also then, by analogy, demote I guess if the array isn't behaving right, you demote. So um, to a lower rank. And this means adding and removing axes. Importantly, it has to be leading axes so that everything is leading axis oriented, and you can use the rank operator to dictate where in the array the new axis is inserted or removed.
Mm.
Right, so let's say we have a vector, it's rank 1, and we do a promote on it, we get a 1-row matrix. So it's a collection of vectors, but there's only that 1 row. And then if you promote it again, then you get a 1-layer, 1-row, 3-dimensional array. But then you can demote it again. But demotion doesn't just work when you have a length 1 leading axis. That's a simple case where you just remove that leading axis. But if you have something else than 1, then you can still demote by collapsing the leading 2 axes. So for example, let's say we have a 3-row, 4-column array, a matrix, and we want to demote it, then we collapse those 2 leading axes of 3 and length 3 and 4 into a single length 12, because there are 3 collections of 4 each. So they all combine into a single collection of 12. So in this case, it would be the same thing as raveling it, which is magnetic comma. But for higher rank arrays, that's not true. And we can do this with a special syntax that I very much dislike, which is the square bracket axis on magnetic comma. So comma is ravel, as you say. That will do that on any dimensional array. It gets demoted all the way down until it's completely flat.
Yeah.
But you cannot limit it to just some leading or inner dimensions. But then the square brackets add this extra kind of meta argument controller. So you write comma square bracket 1, 2, close square bracket in your array, and you will only merge those 2. That's special syntax. And similarly, you can add a new dimension by doing comma square bracket and then a fractional axis.
Yeah.
And that will insert a new axis between the floor and the ceiling of that number, which is very, that one's maybe the worst offender in my opinion, because what is this fractional thing? And so what if you're really close to one axis, then it rounds off to that whole
I
thing.
mean, COD C2.
Yeah, it must depend on, well, it depends on some kind of fuzz. I'm not sure it actually depends
But
on
in
COD C2.
practice, you see, I think people using 0.1 or 0.5.
Yeah.
And that's about it.
Yes.
I don't, you would be crazy to start putting all kinds of random fractional numbers, even though it will accept them.
Well, I guess it's convenient, right? If you want to insert an axis between 2 and 3, then you write *1, that's E. If you want between 3 and 4, you do circle 1, that's pi. It's shorter than writing 3.5 and 2.5.
But I mean, the nice thing is, if you want to model this, you can just assign your favorite letter to, well, comma, square bracket, quad AO minus 0.5 if you want.
That doesn't actually really work because it will evaluate quad IO immediately,
Oh,
and
never
then
mind.
it's stuck there even if you
Oh,
change quad
okay,
IO.
cool. Let's say that's a placeholder for
Little defense. See,
your quad
that's the
AO.
problem. Yeah.
Oh, of course it is the problem. Yeah.
Yeah,
Oh no, you wrap it. You wrap it in a defen.
yes, you wrap it in the defense. So
Wrap it in a defen,
open
localize quad
rays.
IO.
You don't need to localize it. There
Oh,
you can do it using quad IO in the formula because it gets evaluated every time you run it.
and then it'll look for the. Yeah,
Yeah,
but
so
it's
you
not
can.
the calling quad IO. Technically, it's not. It's the
Oh,
lexically scoped quad IO. It's the
if you
quad
want to
IO
call it
where
from
you
far away.
wrote it.
So better to
So you need to.
localize.
Sorry, you need to make a tradfn that looks up the quad IO of the calling space.
Ugh, that's horrible. Don't do that.
Wrap it in
And,
a tradfn. Yeah.
what is there another way to do it?
Depends what you want. If you want a lexically scoped quad
No, no,
IO,
no. I
use
mean,
a default.
and a way that doesn't use the square brackets for the comma. You
Oh,
could, yeah, you
can
can
you
transpose. If you transpose the two leading axes to be at the end of the array, then you can ravel rank 2 and then
and then
transpose
transpose
back
back?
again. So
Yeah.
that would work. And to insert an axis, that's a trick I do currently because we don't have a better thing. I don't like using the square brackets, which is a mix on the ravel of the enclose.
Oh, okay.
So the way this works is that enclose, then we get a scalar that contains our array. Then we ravel that gives us a one element vector. So what mix really does is it mixes up or merges outer axis and inner axis. So the inner axis might be two axes, and there's an outer axis which is a single axis, which is outside of that enclosure, and then it breaks the wall between them and merges them together. So you get the outer axis that has length 1, because we just raveled the scalar, prepended to the inner shape. So you get 1 and then 3, 4 if that was our array. But of course, this is a bit silly to go via enclosure to increase the rank.
I mean, so one of the I say common. I use it mainly. Yeah. Well, I guess it's not too uncommon when I'm exploring things. And then also when you're teaching and sort of showing the results of functions, like an application of this promote, demote, or really promote specifically is you have an array, typically a vector or a matrix at most, typically, and then you have a function that applies to that and returns. It's in some sense scalar, probably. Yeah, no, I guess it would be. Right, it applies to the array, but does something to each of the elements and returns an array of the same shape. And you want to put the input and the output kind of next to each other so that you can sort of compare across and see what the function's actually done. So really common, this is with like a vector, um, especially if you're doing some comparison and you want to check that the comparison is applying to the values. It's giving a 1 for the numbers in your list that you hope it is. So you want to stack the Boolean result on top of the input vector. And yeah, I do flip-flop between I'm already writing a defense, so I'll just parenthesize the output, parenthesize omega next to it, and put a
and
mix
then
on the
mix,
left.
yeah.
Or so that is the sort of multiple element in a vector equivalent to your what you just described, mix, comma, enclose.
Mm-hmm.
Uh, Sometimes if I'm doing it like inline in the session and I'm feeling a bit fresh, then I will do your mix top comma over enclose if simple or just over enclose.
Enclose, yeah.
Uh,
But it's obscure, right?
yeah,
Actually,
that's already a lot to describe.
I just thought about something. You can, with the array notation, there's the square brackets with that diamond separate or new line separated square brackets. Each section there that's separated becomes a major cell in the higher rank array.
So you can define a matrix by open square bracket, expression, diamond, expression, close square bracket.
Yeah, that's a two-row
That's a
matrix.
two-row matrix.
So that means you can do this too, right? If you want to stack things on top of each other, you can just put square brackets around them with a diamond between.
It's pretty tempting, that.
I mean, it's still adding three symbols instead of, well,
Yeah, and it's not like
three here.
the thing of the difference between. So that's I don't know, yeah, a way you can use the array notation syntax to coerce this behavior. But the promote primitive idea is a more core fundamental like array concept, um, which, like you say, we only have as currently as this sort of ad hoc syntax.
And the usage of it is awkward. If you wanted to, what you're describing with promote would be comma bar, so that's first axis concatenation over promote. So you take two vectors, you promote them to one row matrices, and you stack them on top of each other. Right?
Right. It's also, you know, in the
But
square brackets it is comma with the first half, whether that's negative zero point 0.5 or positive 0.5,
yeah, so
depending on your index origin.
dyadic comma that's with catenate, which is then with a square with the axis operators is laminate can actually do this. But if you try to use it as promote, then you need to parenthesize the comma square bracket part after the over,
Yeah, yeah.
because otherwise, yeah, the order of stuff goes all wrong. Because the square bracket has long left scope like any other operator.
Mm.
So we will try to do the catenate first over Revel, and then apply the axis to the entire thing, which doesn't work because axis is ad hoc syntax and can't apply to that. So that's awkward as well. But then you can use laminate, which is concatenate with square bracket axis, which is another one of those ad hoc stuff. And that means concatenate along. Oh, so inside that, if you put an integer axis, it will concatenate along that axis. So that's like first axis, like using rank on first axis concatenation. But if you use a fractional axis, then it will do both. It will both create a new
Mm.
axis and join them along that axis. But that's in my opinion a bit too much. Maybe one of them you want to add an axis to, and the other one you don't. Although even that, you can always append a vector on top or below a matrix and vice versa. It will auto promote there. So maybe there aren't so many cases where you want to use this, where you couldn't do other things.
You can, well, right now you can always do something else.
Yeah, of course you can.
The question of whether you want to eat a glyph for it is, and this is one that it's really hard with all of these, where especially where you've got APLs now, or any like of these array languages that do have you know, clearly a very adequate set of primitives already, in that people use them every day to to
Yeah,
actually do stuff. Is it's hard without having the models to hand, and you know, to really know whether it's worth eating the glyph. Indexing the select one, you know, that we're proposing for version 20 of Dialog is like almost certainly, because you know you, you're always making a little micro decision uh, about your code every time you select things from an array. Every time you have to choose not only, okay, so which type of indexing is sort of given in the circumstance, because you know you generally you either want to select disparate scatter indexing, you know, random pieces, or you want to select um, some rectangular subset, whether that's contiguous or not, but whatever, or you're picking into a nested thing. So that's all given, but you have to choose which syntax you want, like which one's going to be the nicest looking in your expression. So that's always annoying. So it's sort of, and it comes up all the time, like every day. So it's the worst one's obviously squad, where what you don't want to select a like a lesser major cell. Um, like from a 3D array, give me the rows or something, or the third row from the second uh, matrix. I don't want that. I wanted matrices 3 and 1 or whatever.
Yeah, almost
I
always.
yeah, you almost always want to basically do like vectors, but on the higher
High rank.
ranks cells or the major
So
cells or
you
whatever.
can do that by enclosing the left argument, which just makes me think with the uh, before or behind uh, composition, you could just write
Oh, enclose
enclose.
before
Yeah,
squad.
yeah.
And you
But
mean
that only accounts for one of the uses, right? That only fixes the issue with the selecting the major cells of an array. But there's still multi-picking, if you want to call it that.
yeah, right,
So
multiple
it's scatter
items
points, things that you can't
at
easily do
different
like this.
depths.
Yeah, well, then you could do the chipmunk. It's
Mm,
pick each enclose, and and so there are ways to do it. It's just none of it is very elegant or intuitive. And really, indexing the basic indexing function, which is selecting a subset or a permutation of an array, really should. I mean, that is a very fundamental uh, thought concept, in my opinion, and that needs to be a single symbol, no question about it. Should have
yeah,
been.
so that's what I'm saying. That one makes a lot of sense. Uh, Even though it doesn't exist today, why it's sort of would be worthwhile. But
Well, Aaron
promote and
Sue has
demote,
it.
I
It's
find.
just I.
Yeah, true.
Yeah, so
It's just
promote and demote, I mean, maybe not. Maybe it's so rare. I feel like I have to reach for them a lot, but maybe it's just because I'm teaching things and stacking them on top of each other. And mix can always do it. Mix is less safe, by the way, because it will pad if things don't
mm,
conform. Whereas if you promote and stack, then if things don't line up, then it will error,
mm.
which I think then is a good thing. To make sure that you didn't. Sometimes when you do like a pairwise reduction, then you forget that it lessens the length by one because it was one result for every gap between adjacent elements. And then if you try to stack it up, then you can get paired with a zero at the end if you're using mix, and that might not be the right thing to do. This will warn you. So
Yeah.
um,
But in an application, let me see, stacking stuff. You're usually coercing one side into the higher rank first in a way that's not padding. Like, do you do a lot of stacking higher dimensional stuff?
not a lot. I do
Not
some.
a lot. Maybe put matrices up on a 3D array.
Do I do a lot of stacking of higher rank arrays on top of each other? No. No, I don't think I do. But
And
then like, that's like the paradox of array
like,
programming. The most of the arrays people use are scalars and then some vectors and a little bit of matrices, right? I had an example of needing this kind of thing, which was Chronica product. So
you can
we will
describe.
link to it.
Actually,
So
well, no, I'm going to be confused because I think there are a few things called Chronica. So,
yeah,
get the same guy? Does he just
and
did he just do loads of array or
they
matrix
they
stuff?
tend to. So it's really a very simple concept. It's really just
Oh yeah,
an outer
okay.
product,
Hmm.
right? So you have two matrices and you just do an outer product between them. But instead of, so that would normally give you a rank 4 array.
Mm.
But rather than uh, having a rank 4 result, we want a rank 2 result. We want a matrix back again. So we look at the outer two dimensions as being uh I don't know how to describe this really. It's like you have a matrix of matrices, right?
Yes, yeah.
A four-dimensional array is like a matrix of matrices, and then you just join them up.
To make one big
Big one,
matrix.
yeah. So you just glue their sides to each other, top and bottom, right, left. Um, and for that, That's exactly what demote would do.
Yeah, right.
And doing it
Would you
with
demote twice, or would you
yeah,
demote?
demote twice because you add each time you demote, then you're demoting
You're merging the
merging two X's. Yeah.
first two.
Yeah, so
Yeah.
you need to merge the first two, and then you need to merge some inner two, so you need to use the rank operator. But it's not very complicated, really.
Mm.
And really, that kind of hints at maybe promote mode is not the right thing to do, because if you look at the
Because there's an alternative. You say it's an outer product between two matrices, but is it the same as uh,
if you do
I
the
guess
one
not. I'm thinking about
times the enclose,
enclosing one of
yeah,
them.
exactly. It is the same thing as enclosing one of them because of scalar extension. But and then you do a
Pick,
con
comma, compress. No, sorry, pick,
no,
comma, reduce. Pick.
yeah, first whatever. First concatenation reduction
Yeah.
also a concatenation first axis reduction as well. But that's highly inefficient, right? You're doing it like that.
Well,
You
this is this. That's another one of my general qualms about this aspect of language design, where you're like making developing the language in the direction of um, I want to manipulate. Well, how can I phrase this? I was going to say in the direction of I just want to manipulate arrays, which sounds like a well, duh, like you're
no, I
developing an
think
array-oriented language.
I think what you're getting at is that you'd like to express yourself in the way you think of it and not worry about the underlying representations of it. So you say it's highly inefficient. Yeah, but the way I think of it is, okay, you've got these each
Yeah.
element from this array is multiplied by the entire one of that array, and then we have even looks right on the screen, and that's what I want. Now I just want to merge these, just glue them
So
together.
maybe that, I mean, that's also the curse, isn't it? Is we have this distinction in APLs of
Hmm.
uh, nested depth enclosed arrays and high dimensional ranky arrays, and they're not the same thing. Primarily due to like raggedness, like how they treat raggedness, the fact that you don't like the high rank thing, you have to like
It's,
pad and
but it's more than
stuff.
that. It's more than the way I think of them is in encapsulation. My enclosures allow me to define the level at which I'm working. So a very simple example of this, let's say I have the text hello. Okay?
Mm,
And then if I do 10 reshape hello, then I get a single character vector hello hello,
yeah,
10 characters. That's because the unit I'm working at, the enclosures, implied enclosures, whatever, are the scalars that are there, the simple
yeah.
scalar characters. If I want to work on the unit of the entire text, then I enclose it. Now at 10 reshape that, I get 10 hello hello. Hello, hello. I mean, hello, 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 etc. Right? Um,
Yeah,
and the same way here with these matrices, I want to work on the unit of the entire matrix, so and each one gets then multiplied by a scalar from the other matrix, and then I just want to merge them. And so I think there's is it an issue? There's a kind of conflict between, on one hand, I can use these enclosures to encapsulate what I want, the units that I want to work on, and then express myself in a natural way at the cost of performance, because
yeah.
as far as I know, no APL interpreter is well geared to handle those nested cases performantly. They can't figure out what the equivalent uh
And I mean, in the example
nestings
we're
are.
talking about, the only difference is that like it feels conceptually harder to imagine or rather, the display form of a 4D array is not the matrix of matrices that you're imagining in
Right.
your head, whereas the display form of a matrix of enclosed matrices is exactly
But
that.
it could be. There was a recent discussion in the APL farm and about how what would be a better way to display arrays, and somebody suggested that every other dimension could be vertical on the screen and every other dimension
Mm.
horizontal. So then you would see a rank 4 array as a two-dimensional array of two-dimensional arrays, with proper indication of what's nesting and what's ranking, basically.
Yes, of course. I
So
imagine the design
it,
space that explodes.
yeah,
Uh,
but it's possible. It bothered me then that we don't preserve the revel order, but maybe that's not really a big problem. We don't anyway. We don't preserve the enlist order if we do it nested. Uh,
Right.
so and I think duality is a good thing to have. And there are things you can only express properly in high rank array model. The things you can only express properly with the nested thing.
Yes.
Not
Yeah. I
different
do.
models, but yeah, so data structures you can't really express.
Yeah.
Um,
I
so
agree with that. It is really only specific applications where you're doing something and it turns out it's equivalent to this other expression, that might be more performant or, you know, more or
But
closer to how you're thinking or
then you can
whatever.
fine tune where it's important, right? So sometimes you can find flat alternatives and algorithms to your otherwise nested thing. And if you only do a little bit of the nested thing and it's not performance critical, then yeah, the way you think about it is probably fine. But if it is performance critical, then or something you do a lot, then it's worth investing in finding in the compare the equivalent flat version, which is not the way you think about it, but you can learn to reason in that direction. Say this is the same thing as that.
Right, yeah. My, it's a big question, isn't it? It's like there is this wealth of like these techniques historically, but when you're teaching people and stuff, it's obviously often easier to just go, well, just enclose and do each partition and apply on each, whatever.
Yeah,
Because those,
but
uh,
even there could be a primitive missing, actually. And so when we have this matrix of matrices and we want to join those into a single matrix, then we have to concatenate along each axis, concatenate reduction along each axis, and
right,
then we
or
have to
demote
disclose.
twice or whatever.
Well, the modeling choice you can only do if you then increase the rank instead first. So if you do a full
Oh,
mix.
sorry, right. We've got
If
yeah,
you got the enclosed one, then you
yeah,
need to merge the inner and outer axis. So it's like mix. Maybe mix is maybe not the best word for it. Mix is an inner and outer axis concatenation. Here we need a different thing. We need inner and outer axis um merging or uh
yeah.
yeah, collapsing because we want the leading axis, the outer leading axis should be the same as the inner leading axis, and the outer trailing axis should be the same as the inner trailing axis. So you have, let's say you have a 2 by 2 matrix of matrices. So then, you want the you basically want to enumerate all the row numbers you have. So the first matrix has rows 1, 2, and 3, and the second one has rows 4, 5, 6. And then you want to join those together so you have one final array that has rows 1, 2, 3, 4, 5, 6. And the same thing goes for the columns. That's a different type of operation. And yes, you can write it currently in APL, and the general form is really awkward. It would be a uh, a reduction over the collection of x's with
Mm.
the array itself. So for each dimension, you go in and join those. But it's not very elegant. And there's there's definitely room for a primitive that could do that. And BQN has that, interesting. I think J has something like that as well, but it's not as general. The
This is
arrays.
join
Yeah.
arrays.
Yeah, it's a generalized multi-dimensional uh disclose concatenate reduction
Yeah, right.
that doesn't destroy its data um, by messing with the other axis. That's another candidate. Somebody suggested that would be a good candidate for the monadic meaning of the right shoe underbar. So if you use right shoe underbar for select, dyadic is select, just like the right shoe is dyadically pick. And
Mm.
then but monadic and right shoe is is a disclose. Question is which type of disclose, and that's a difference between the implementations of APL. Is it the disclose by just taking the first best element, or is it disclose by disclosing all the elements and joining them? together and forming higher rank. So that's a mix. Um, and but it's definitely a type of disclosing. And this merging operation of merging all the x's is also a type of disclosing. So it kind of makes sense. That would be right shoe underbar like that. And
Maybe.
yeah, I mean there are different possibilities. Unfortunately, we're mainly talking about this for dialog APL. And dialog
Mm.
APL went with the original specification from the nested array system that the right shoe is first and up arrow is mix, whereas APL2 and its kin
Mm.
have it the opposite. And so it kind of doesn't sit well with me that the mix type thing is the up arrow, and then the merging operation would be a right shoey thing that sort of mixes things up. Then I got this idea that maybe you could use something like greater than, magnetic greater than. That's kind of like a right shoe, but it's angular. And
Oh
that
yeah.
then I could justify it a little bit by saying um, up and down, that's rank. So remember the proposed symbol for
Promote
promote and
is
demote was
yeah.
this up arrowhead and down arrowhead, whatever they're called.
Yeah.
Mix and split, or magnetic up arrow and down arrow, they also change the rank, at least in the normal cases, they do. Right? By combining they take inner axis and add to the outer axis. So that normally would increase the rank. And split does the opposite. It takes a trailing axis and hides it away in an enclosure. It's the same thing as enclose rank 1. And so it lessens by 1 the rank. So anything that's up and down pointing, that's increasing and decreasing rank. And same thing with promote, demote, just up and down pointing arrowheads. Left, right, that's for the depth. So if you do a left shoe, right, that increases the depth. And a right shoe, because that's enclose, right? Or even partition and partition enclose, they increase the depth by adding partitioning.
Yeah.
Whereas right shoe lessens the depth, it opens up, right? So it's a first, takes the first element that has 1 less depth than its container, or pick, which also lessens the depth by digging into an array and picking something out. And so too, it should be right left for this merging thing, because that also lessens the depth by combining the inner and outer axis, just gluing them together rather than concatenating them to each other. And so it would make sense to make that greater than the possibility. Or right shoe underbar. That's also a possibility. This is, yeah.
The possibilities are endless.
Yeah.
So you have you can
I,
wrap this up by talking about a couple of things. One, you have dialogue extended and you have dialogue APL vision.
oh, so these are, now you're talking about the GitHub repositories.
Places to actually
Dialog extended is
try
dead.
things.
Right? That extended was a wild ride of like try to extend everything as much as I can. But it was ultimately killed by dialog version 18 because so what I tried to do is just like to extend the domain in a natural way of every primitive, not trying to add this useful functionality. So for all the comparison, the scalar comparison functions, less than, equal to, and so on.
Yeah.
What I'd done was I thought that a useful default left argument would be the prototypical scalar element. So for characters, it would space, and for numbers, it would be 0. And then that gives you some interesting functionality. That would mean that monadic less than is the function is positive, because it's greater than, if it's 0 is less than that, then the array, then that gives you all the positive ones, and less than equal to would be is it non-negative, and so on, or and equal would be is 0, and unequal is non-zero, which is often very useful, right? And for characters, it gives an interesting split. It happens to be that in Unicode, the space is exactly in the split between control characters below it, and ASCII 0 through 31, and non-control characters, ASCII 33 and up. And so it would allow you basically to say, if you say greater than and some text, it will give you ones for all the control characters. And greater than equal to would be all like control characters in white space, and all if you did less than or less than equal to, you can with or without space, without and with space, say what are the printable ASCII characters or printable characters in general. Whatever, it's kind of cute. But then 18.0 dialog added monetic different from unequal to be the nub-sieve or mark unique or whatever you want to call it.
Yep.
Unique mask. And then I gave up on that. And also it wasn't really realistic. It was doing insane stuff like floor and ceiling being uppercase and lowercase and things like that. Oh, so then
I see.
after a while, but it also had an implementation, like a model for it, and you could run it and try it online, and that gives us backwards compatibility issues in the thing itself, which is not very good for that kind of thing. So dialog vision is more trying to be more realistic. And there I'm not afraid of changing anything, and there's a warning about that it might change. It's not stable, and that's more along these lines. And there I have these kind of primitives to play around with. Yeah, can have a look there. We'll link to that.
Yep.
I changed things as late as last week. Yeah. Well, we'll continue this discussion eventually. Another primitive that the reason I was kind of refraining from saying, "Oh yeah, right shoe underbar," that should just be that merging thing, even because that's a useful operation. Something really down to earth, a simple thing that I would like is the last primitive, which I can round off of that because there's not much to say about it. It's just disclosing and taking out the picking the last element of an array in Ravel order, just like we have a first primitive. It's very simple. And it's even an idiom, meaning a dialog idiom, meaning the interpreter recognizes the phrase first reverse Ravel. Not that you often need the bottom right corner of a matrix, I don't think, but the last element of a vector is really often useful.
Yeah.
And it's a bit awkward to write first a top reverse, and often I find that I want to apply a function on a pair. So
First and
I do it.
last.
Yeah, exactly. So I want to apply it with a reduction on that pair, so that would insert the function between them. But if I don't have to do that because I can just do first and last inside, say, a train and so on. That would be more elegant, and I don't have to worry about it enclosing because of the reduction and things like that. So there's some things to be thought about. It's not going anywhere right now. Extravaganza, huh?
Well, yeah, it's extravagant and Anza.
Yeah.
Anyway,
we can ask the listeners and viewers to come with their own input on what kind of things would they want to see. You can email us at contact@apl.show, which also hints at our website, tiny little website, apl.show. It's just where you can find the recordings and show notes and so on. We'll continue this discussion another time.
for sure.
It's been great. Thank you so much, Richard.